So really, as part of today, it's understanding how to go from a system of 2 equations. We're only working with 2. We're not working with 3 equations for these. So how to write a system of equations as a matrix equation is one part of it. And then understanding how to solve that, how to get the solution is another part. And really, the way you solve a matrix equation is going to be the same every time. But what we'll go through is why. Why that's your solution, why that is how you get your answer, no matter what. So the examples are really going through on the back. This is just explaining and putting together everything that we have. So we have here, if this was our system of equations, this would be the matrix equation that we would set up for that system. So we have the, or it says write the left side of the matrix equation as the product of the coefficient matrix and the variable matrix. So you have your coefficient matrix. What you do need to make sure of in your system is just like if you were solving using elimination, you want to make sure that everything, all of your like terms and your equal signs are lined up. So it doesn't really matter if this column is y and this is x, but you want to make sure they are lined up. So we have our x's here, our y's here. The coefficients of those terms go in our coefficient matrix. So I'm going to highlight here. So I have the 1 and the 3, and then the 2 and the -6. So I have my x column and my y column for my coefficients. That's my coefficient matrix. Then I multiply that by what's called the variable matrix. So your coefficient matrix is always going to be a 2 by 2. Your variable matrix, in order to multiply, in order to set these up so that they could be multiplied, your variable matrix is always going to be a 2 by 1. So it's going to be 1 column, 2 rows with your 2 variables. What I do want you to notice is that the variable that is in column 1 here, if these were switched around, if this was y and this was x, these would have to be switched. So since x is my first column, x here is in my first row, and then y is my second column, so y is in my second row. If they were switched, if these columns were switched, these would have to be switched. Just so you're aware of that. But if you always line it up with x's first, then you wouldn't have to worry about it. And then you set it equal to, you write the right side of your system as a constant matrix. So our constants go in their own matrix, and that is also always going to be set up as a 2 by 1 matrix. So just 1 column. And then these are the steps you would take to solve it. So if I ask you to write a matrix equation, this is it. Notice they're calling the coefficient matrix matrix A. The variable matrix they call matrix X because you're always solving for the variable. And then the constant matrix they refer to as matrix B. And so this is comparing if you were just to solve any equation with numbers and then the steps you would take to solve a matrix equation. So I want to kind of compare these as we go. So this example would be like if I was doing 3x is equal to 12. That's what this is referring to. And then this is a matrix equation. So you have your equation. Normally, if you were solving this, you'd probably look at it and say, I'm going to divide both sides by 3 to solve for x. We did talk about, or I mentioned Friday, that we don't have matrix division. So that's why we have the inverse matrix. Dividing is the same as multiplying by the inverse. So I could divide by 3, but that's the same as if I multiply by the inverse of 3, which is 1/3. So this step would be if I still have my 3x equals 12, but I multiply each side by 1/3. So I multiply each side by the inverse. And then that translates to matrices, matrix equations, because I can actually find the inverse of matrix A, and I can multiply both sides by the inverse. Notice, since the order you multiply matrices matters, that I'm multiplying by A inverse on the left side. So I have A inverse times A, and then on this side it has to be A inverse times B, not the other way around, not B times A inverse. Then When you multiply inverses, like I know 1/3 times 3 would just be 1. So when you multiply inverses, it's equal to 1 when you have numbers. So this would be 1x is equal to 12 divided by 3. On this side, when we multiply inverses, we learned Friday, you get the identity matrix, which is like the equivalent of the number 1. And then 1 times anything, 1 times x is just x. So here x is just equal to 4. And on this side, this is always going to be your solution. So you do not have to show these steps every single time. This is just showing you why this is your solution. But whenever you are solving a matrix equation of this form, to find the matrix X, it is always the inverse of A multiplied by B every time. So if you can remember that, you don't have to do these steps every time. So we're going to go through a couple of examples so you can see how this works out, and those are on the back. So this is how I have it laid out because I want to see that you know how to set up a matrix equation, you know how to find the inverse, and then you know how to solve the matrix equation. So it says use a matrix equation to solve this system. And this is actually the system from the front. So when I'm setting up the matrix equation, again, it's my coefficient matrix. So that would be my x column is 1 and 3, my y column is 2 and -6. So I have this 2 by 2 coefficient matrix multiplied by my variable matrix, which is 1 column, and since my x's are first in my equations, it's going to be x on top and then y. And then that's equal to my constant matrix, which is 1 column, 9/3. And they, again, had this labeled, the coefficient matrix is matrix A, the variable matrix is matrix X, and then the constant matrix is matrix B. So A times X is equal to B. And then based on the steps I showed you on the front, I know that in order to solve for X, I need to know what the inverse of this matrix is. So it says find the inverse of matrix A, and that's where we do what we did Friday. We use this formula. So to find A inverse, I do actually need to know the determinant of A. So we'll do that over here. The determinant of matrix A. And again, that's your main diagonal product minus your other diagonal product. So I'd have 1 times -6, so -6 minus the other diagonal product, 2 times 3 is 6, and -6 minus 6 is -12. And if this is 0, that means you actually can't find the inverse, meaning you wouldn't be able to solve this equation that way. So for the problems you will have that I ask you to do this for, this should not be 0, because I don't have any that I'm not going to ask you to solve a matrix equation that you just can't solve that way. So this should not be 0, but if it was, you'd have to find a different way to solve this system. This way would not work. It would also mean that there's not a unique solution. It would either be no solution or infinitely many. So since this is -12, I have then 1 over my determinant, 1 over -12, multiplied by, and then remember this matrix is just coming from switching these around a little bit. So your main diagonal, the elements just switch places. So then 1 and -6 will switch. And then the other diagonal stay where they are. They're just now the opposite. So instead of +3, +2, I have -3 and -2. And then I simplify that. So I actually do divide all of these by -12 and simplify. I'm going to keep them as fractions. So if I have -6 over -12, that would be a +1/2. You could write as 0.5 if you wanted to. A -12 or -2 over -12 would be a +1/6. -3 over -12 would be a +1/4. And then 1 over -12 would be a -1/12. So this is my inverse matrix, A inverse. And then again, I'm going to write this out. You wouldn't have to write this out every time, but I'm going to write out again why the solution is set up the way that it is. So if we have our matrix equation A times X equals B, because now part C, it says to solve the system by solving that matrix equation. So again, these were the steps that if I want to solve for matrix X, I have to multiply both sides. I have to get rid of matrix A, and since I don't have division, I multiply by the inverse. So I am doing A inverse multiplied by the right side, or I'm sorry, the left side, and then I have A inverse times B on the right side. So I multiply both sides by the inverse, and notice the A inverse does have to be on that left side of both. These two end up canceling out, or they become the identity. So then I'm just left with X is equal to A inverse times B. But again, this is always going to be how you find your solution. If you just forgot that, this is how you could figure that out. So if I have up here, I'm going to set this up. So here's my matrix X. I'm just going to fill in my matrices. So matrix X is my one column, XY. And that's going to equal my A inverse matrix, which is what I found in part B. And then multiplied by my matrix B, which again from my equation up here is the one column 9, 3. And then notice too why the multiplication has to be in this order. You have to be able to multiply the matrices. So this matrix A inverse, this is a 2 by 2. The matrix B is a 2 by 1. So if I had this order switched around, I actually wouldn't be able to multiply those. These I can multiply, meaning my answer, since these twos are the same, my answer should also be a 2 by 1 matrix, which makes sense because it should match this matrix here, which is 2 by 1. And then when I multiply rows by columns. So my first matrix does have 2 rows, and then I just have the one column here. So here I have X, Y is equal to, so if I do row 1 by this column, I would have 1/2 times 9, which I'm going to keep these as fractions right now. So I'm going to write this, this is like 9 over 1, so that would be 9 halves. And then plus 1/6 times 3, which would be 3 over 6. Or I'm going to write that right away as 1/2. But it would be 3 over 6, which is 1/2. Okay, that's my row 1, column 1. Now I do row 2, column 1, and that would be in row 2. So I have 1/4 times 9, so that would be 9/4. And then plus a negative 1/12 times 3 would be negative 3/12, which is negative 1/4. All of these you could have written as decimals as well. And then if I simplify that, so 9 halves plus 1/2 is going to be 10 halves, which 10 divided by 2 is 5. And then 9/4 plus a negative 1/4 would be 8/4, and 8 divided by 4 is 2. So I get 5 over 2, or the matrix one column, 5 and 2. And now here's how you write your answer. You're still solving a system. It should be an ordered pair. This means X is 5, Y is 2. So my solution to the system is the ordered pair 5, 2. And it's still a system, so I could still substitute those two values into both equations and make sure that it works out. Questions there? Okay, so yes, it's a process, but I do have it split this way for you. So even on the test, I'm grading 1, do you know how to go from a system to a matrix equation? Then do you know how to find the inverse? And then would you know how to take that equation from part A and solve it? Okay, so there's really three pieces I'd be testing, but I would have it laid out that way for you. So I'd like you to do example 2. Solve that system by setting up a matrix equation, finding the inverse of A, and then solving the matrix equation.